Hey everybody, today we'll do another video, and today we'll do another video in this topic, what is called either digital logic or digital systems. Basically the same thing, right? So right here, I have an OR gate and a NOR gate. Not NOR is mean not OR, right? So basically over here I have an AND gate, and it's the same thing, just we write it with a little bubble like this, because technically this will be like that, right? So technically they will be written like this, right? This is a NOT gate. NOT, right? But we don't write it, well, to make it easier, this is an N gate. So I am saying not N, right? So not N, right? NEN. That's why we call it NEN gate. We call this NEN gate. Okay, so we call that NEN gate, and normally we just put a little bubble here. Little bubble. Right, that's the same thing. Okay, so NEN, a NEN gate, right? NEN gate means not AND gate, right? I am negating whatever that I'm doing right here, whatever the output is. This is the output, right? So whatever this is, I am negating, right? That's what I'm saying, right? So with that being said, because we're not gonna be dealing with this today with the NAND gate, right? So, but I have the truth table for the OR, for the NOR gate, right? For the OR gate, this is the OR gate table. You know that the OR gate, everything equal to 1 over here except when A and B equals 0. Same thing over here with something different. All right, so over here you get it. The only thing that make this is the table for this, right? So you can see that the only way to get 1 over here is when A and B are 0, you get 1 over here, right? When A and B equals 0, then you get 1 in the output. Okay, so now for the meantime, we will be dealing with this. We don't need this right now, right? So I just want that just to show the table for. Eventually, we probably will do one with using the NAND gate. But at this moment, I have your diagram over here for the NOR gate, right? So it's the NOR gate. So these are two NOR gates, right? Now I am going to write a little table for this that to represent this. But first, I want to actually let me do that right now, so it can make sense of what we're doing. So the table for this, right? So we're doing what is called the SR Latch, right? And this is the SR Latch, right? So I went to write a truth table that represents this. So the truth table is, so we got R, we got S, R, right? And we got Q and not Q, right? Or Q bar, right? Now, so Q, N, Q bar are output, right? Q and QR are output, right? So now in this case, let's drop another line over there. Okay, so let's make this table. Okay, so we have, right? So we have what? We have the possible input for this will be 0, 0, right? Well, if I have used the NOR gate, 0, 0 is equal to 1. Equal, you can put 0, 1, and this is the tricky part in this. Well, it's not really tricky. It's just basically, I will explain it. When we do it right here, it will make sense to understand the table, right? So, right here, in this case, when that is true, right? So you can do this either way, but you can do it this way. So you got 1, 0, right? Assuming that at this moment, this value is 1, this is 0, right? So now we will do at this moment time, when this happens, this can be either when this is equal to 0, this R and S are equal to 0, right? So when those are in place, for example, when those are equal to 0, this state can either be 0, can be 1 or 0, or 0 here and 1 here, right? So these are the possible outputs when these two are 0. And I will explain it when we do it over there. Okay, next, we want to do the rest of the table, right? So at the point of 0, 1, this can be either 0, 1 over here too, right? And then we do 1, 0, 1, 0 again back here, right? And I will explain that. So now let's do this. So now I do yes. So I am here. Now the last one is going to be 1, 1. It's going to be at that moment. This is going to be equal 0, 0. And I will explain this when we do this. Okay, so this is the table for SR Latch. Okay, so now it would be nice if we can actually, draw this, change color, but well, I can try. And I cannot promise that it will be coming out correctly, but I can try. Okay, so let's say that we start with, Q is equal to 1, right? Okay, so let's say that the state, first state, right? So this is 0, okay? And this is 0. Okay. At that moment, assuming that Q is equal to 1, and I will say that why we assume that. So R is 0, S is 0, S get input over here, right? When the S gets input over here, right? So assuming that when S is 0, is equal to 1, right? Comes over here, right? But now, okay, let me explain this again. Let's assume right now that this just, that's nothing, right? So, okay, think about it. So I get a 0 coming in, and this one. 0 coming in here. 0 gets it turned into 1 coming in back here. This is 1. When this is 1, this 1 right here, because this is 0, I am negating it. I am saying that this is not 0, which is, I am saying that 0 is 1. This 1 comes in over here, get fit into here, right? This output of this OR gate, this NOR gate, is affecting the input of this NOR gate. Now, this is 0 input coming in. That 0 is now is 1 because it's not 0 now. I am saying that this is not this 0. So not 0 means this is equal to 1. That 1 gets input into this gate, right? Now, this gate right here now get invert, right? So this is in the NOR gate, this 3 are 0, right? So what I'm saying is that when this 0 comes over here and goes over here to the input of this one, so this is NOR gate, now this is 0, this is 1, which this becomes what? This becomes 0 back here. So Q naught is equal to 0. I'm 0. Q is equal to 0. Q naught is equal to 1. Right? Now, that 0 comes over here again and fit into this. Now this is 0. See how that makes sense, right? Now this one is 1, right? Well, it was 1 initially, right? So now, because this input is affecting this, right? So this input is affecting that, right? So as you can see, this one is in green. Right? Now, what happened over here is that this right now this, as you can see, initially was 0. That 0 get turned into 1. That 1 get fed in this, making this input, making this output, making this output goes into this input, making that one, which now that is equal to 0, right? because I got this combination 0, 0 and 1, 1, 1, 0. Now, okay, so now let's make it, now this is state, right? We're saying that this is equal to 0, but because this is equal to 0, the output of this is fitting into this, making the Q naught is equal to 1. Now, what if I changed this, right? Making sure that we erase all that. That was in the first state, right? Now, one thing to remember that, like I said, when that's equal to 0, see, it can either switch back and forth, right? It can be this and this and this and this 4 combinations. Now, this over here is considered invalid. This is considered invalid. But we'll work with this though, right? With this 4 combinations. Okay, so let's say, for example, now that S is 0, R is 1. S is 0, R is 1. S is 0, R is 1. Well, let's do this. Right? So let's say that this is equal to 1. 1 is coming over here, right? And that 1 is converted to what? Converted to a 0, right? So this is, okay, or you can look at it this way. So I got a 0 coming in. I got a 0 coming in, right? 0 coming in. That is equal to, okay, let's do it this way. You got a 1 coming in. That 1 is converted to what? To 0, right? Assuming that, I mean, you can, assuming that this is 0, this is 1, right? Assuming that this AB instead of, whatever. I mean, no, we'll just keep it like this, just, okay. So, assuming that this is S and this is R, right? So, now, look at this. Now, let's make sense out of it. Okay, so let's say that, let me start with this. Okay. Let's say that S is 1, comes over here, negated, that's equal to 0. And then this is 0. That 0 comes in, fit into this, right? Coming over here, actually. That 0 comes in, right? Comes over here and fit it over here, right? What is going to happen? Like 0 is 0, right here, that is equal to 1. Right here. Okay, so that's equal to 1. Now, this 0 comes in over here and fit into this. Now that this 1 comes over here and fits over here, right? Now, 1 and 1 in this case is equal to 0. So 0 comes over here, right? and fit it into this, right? And go back to it, right? Okay, so that makes sense. Now, let's make this 1 and this 0 now. Okay, so let's make R is equal to 1 and S equals 0. Okay. This is coming in over here. This is equal to what? This is equal to 0. Right? So this is, okay, got a 1 coming in. You got a 0 coming in. Right? Back to the same thing. Right? So this 0 right here coming in. Right? This is 0. This is a 1. So negating that is equal to 0. Right? That 0 gets that output comes over here, go to this input, right? So what is going to happen? Now, this is 0, right? This is 0, coming to 0 right here. Now, I am getting back 1, see? Now, it's 1 coming out, right? Now, let's do it again. Now, let's do, in this state, let's do, so now, let's compare with the table, right? Let's compare this with the table. So, 0, 1. 0 comes in. Go back, it's a 1. This is a 1 coming back. Goes back, fitting in 1 here. 1 and a 1 is equal 0. But remember, I am not pressing, it looks like I'm pressing the 2 at the same time because I got a 1 coming in over here. But it's not what I'm doing. I am not pressing 2 at the same time. Pressing 2 at the same time is symbolic. So I am pressing 1 at a time. In this case, S is 0, S is 0, R is 1. S is 0, R is 1. When that happens, S is 0, R is 1. S is 0, R is 1, the output is equal to 1. See that? Now, let's do this again one more time so we can understand what is going on. So let's do 0, 1. Now, 1 comes in. That one gets turned into negating that one. That one gets turned into what? Negating that is going to be equal to 1. Now, coming over here. This one comes in. Fit into this one. Now, 1 and 1. 1 and 1 is equal to 0. So this guy now is 0. Go back. 0. Okay. Go back to it, right? The 0 goes back here. Once 0 nor with another 0, 0 nor with another 0 is equal to 1 again. Now, look at this. When when R, when S is 1, when S is 1, R, when S is 1, R is 0, Q is 1. Q is 1. Right? When, do this again. When S, okay, so when S is 0, R is 1 again, right? When S is 0, R is 1. Again, comes over here. This becomes 0. The 0 gets fed into here, this input. Output comes over here and gets fed into this input. 0 comes in, and that is equal to what? That is equal to 1. I hope this is clear. When S is 0, R is 1, Q naught is equal to 1. So this is important because it takes the bit and keep it latch, in other words, to save it, and remember that the previous state, right? The only thing that are not valid is when I press the 2 at the same time. This when that equal to 0, both of them equal 0, right? So, because this is set, this is reset. Okay, so now the question is, right? What if it was on, right? It was on, but you turn it off. How we know what bit was saved before it was turned on? Before it was, yeah, after it was turned on, what state it was. That's why we assume one of them. In this state, we assume that Q naught is 1, right? Let's say, for example, we assume Q naught is 1. And say you make the two states starting at 0. To make this red. The two states starting at 0. But you don't know which one it was saved in the previous state. You don't know, right? I don't know. Like, I have this electronic device here, right? I turn it off. When I turn it off, do I know what bit was there? Was 1 or was 0? I don't know that. That's why we assign, even though we start with zeros, we assign 1 to them, right? We assign, assuming that one of them was on. In this case, I am assuming that this is a 1. So assuming that this is 1, I'm sorry, assuming that this is 0, the both are 0, right? Set and reset are 0. assuming that set and reset are 0, so I have a 0. 0 is equal to 1 in this case. I am negating that, right? That is the previous bit. That was there. That previous bit was not erased, right? It was basically which transformed one bit to another, right? So assuming that bit is there, that previous bit that it's there turns into here, right? Which making this a false statement. It will return a 0. Go back to this, feed into this input, because it's 1, right? So now this NOR gate becomes, as the output is 0, right? Comes in, right? Comes in, right? So 0, that 0 gets fed back into the previous, into this, right? Which making this 1. Do the reverse, right? What if I assume that is 1, right? What if I assume that was 1 and then that was 0? The same thing. So that's why you can start with zeros, right? Or you can assume that there's a bit over there that was saved in that from the first state, and that bit can be 1, it can be 0 or 1. So obviously, right? There's 1 over here. It's coming in, even though they both are 0, because obviously that 0 coming in, it fit into this, right? Which making this 0 and 0 equal to 1. 0 and 0 is equal to either Q equal 1 or not Q equal 1. So in this case, I am using this right here. I am using that when they both are 0, not Q is 1. Not Q is 1, and that because not Q was 1, that output gets fed into the input of the R, right? And then that make this statement again 0 and get fed back to it. Okay. So now again, one more time. One more time. Okay. So now, let's assume that now Q is 1. Let's assume that Q is 1, and they both are 0, right? They both are 0. Okay. Does it make any difference? Okay. Okay. So this is 0. It goes over here. That turns into a 1, right? Because it was there, right? That 1 gets fed back into this, which make this what? Make this 1 0. Now, let's assume now that, okay, so you can see that when S is 0, when S when okay, so let's assume now, this is what I was trying to say. That is 1. Right. So let's say, for example, but normally we'll start with like this. Okay, so then I don't want to confuse anybody. So, okay. So let's do this, right? So R is, let's assume that R is 1, right? That one gets fed over here, this is equal to 0. This 0 gets fed over here. If that is 1, that is 0. And that's 0. So now this one is 0, right? This output gets fed in this input. That 0 is going to get fed in this NOR gate with 0 and 0. Now this guy is equal to 1. Now, go back again. This one gets fed over here. So that gets fed over here, and this is a 1. So now this is what? This is 0. And back and forth. The only thing, the beautiful thing about this is that you cannot, it isn't matter to press 2 at the same time, right? And technically, that makes sense too, because how you know that you actually pressing the 2 buttons exactly at the same time? So, which creates a problem called debouncing. But again, I'm not going to talk about that right now. But when you tend to press 2 buttons at the same time, right? So that is, it creates an issue that's called debouncing. But again, this is another topic, and I don't want to. But anyway, so 0 and 0 over here is equal to 1. That 1 gets fed back here and creating that right there. Again, we can do this one more time. One more time, that's it. Right? So now, so let's do 1 and 0, right? Let's do 1 and 0. 1 and 0. Again, because, okay, so the 0 gets turned into 1, right? That 1 comes back here, right? That 1 gets fed. This is 0. Get fed over here. And that one and this one is creating that, because this right here is equal to 1, right? So this is 1. So this is 1. That 1 gets fed into this, which is equal to 1, which now this becomes 0, right? This becomes 0 and gets fed back into this. Right? You can see this output now becomes the input to this, which make this true, because when S is 1, Q has to be, when S is 1, right? When S is 1, Q not 0. When S is 1, and when S is 1, right? And R is 0. Q naught is 1. You can see right here. I'm sorry, Q is 1. And Q naught is 0. See that? And I want to repeat again. When S is 1, S is 1, S is 1, R is 0. S is 1, R is 0. Q is 1, Q naught is 0. Q naught is 0. And Q is 1. Hopefully this is clear, and I see you guys in the next video. Thank you for watching.